Hello students, welcome to the GATE Academy. I hope your preparation is going well. So as we all know, we have started the GATE booster series, and in this series we have discussed so many subjects with regards to every engineering streams. Right now we are discussing the mechanical engineering stream, and for the subject will be thermodynamics. Again, one of the most basic subject, and most of the questions in the GATE examination, as you all know, as thermodynamics is a basic subject, application subjects are more like power plant, IC engine, RAC, even the heat transfer also, because thermodynamics is just a basic concept. Many 3 or 4 application subjects are there. So if we have command on the thermodynamics subject, then definitely we can do better in different subjects, okay, application wise subjects. Okay, I hope this is clear to everybody, because always remember this one thing: when you have a good command in the basic subject, then definitely you can do the application subjects very easily. Okay, so just for that we will be discussing some beautiful questions from the thermodynamics subject, because after solving this particular questions you will be in a position to solve any type of question that may come in your GATE examination. Okay, so confidence is required for the GATE examination. You have learned all the concepts, you have learned different formulas, different concepts, everything you have done, but for the confidence you have to solve different variety of questions, and we are here just to bring some new different variety of questions that you have not solved earlier. Okay, in regular classroom we have solved some PYQ or some basic questions, but in this score booster we will be discussing very different questions. Okay, multi-concept questions will be discussed. I hope this thing is clear to everybody. Now we will be starting the session. Please share this particular session to your friends so that they get also benefited from this particular session. Okay, and in this series, in this score booster series, while solving the question we will be discussing the concepts also. Okay, it is not just like that we have to solve the questions, we will be discussing the concepts also, because concept is required for solving any question. So we will be starting we will be discussing the concepts part also. Okay, so we will start the session. We'll start the session, and the topic for the today's session will be what? Thermodynamics. Okay, so we'll start the session. Just 1 minute. Gautam, good evening, good evening. Ravi Shankar, good evening, good evening. Okay, so we'll start the session. So we'll be going in this session, we'll be going through some basic numerical, then we'll be increasing the level of questions. Okay, so the first question is in front of you. Please try to solve this question, because it's a very basic question, as I have said. So try to solve this question. As we proceed in the session, we will be solving some different and highly difficult questions also, because that is required, in which various concepts are required from different chapters or different subjects also, right? We will be discussing that questions also, but just for the starting purpose I kept a very easy question. Please try to solve this question. Just try to solve this question, very easy question. Okay, so in this question they have said a vessel of 3 meter cube volume is there, which is contained what? The hydrogen. The container contains what? The hydrogen at atmospheric pressure. Most important point you have to notice that atmospheric pressure. At atmospheric pressure the gas is there, and they have mentioned the temperature, right? They have mentioned the temperature. An evacuating pump is connected to the vessel. Okay, evacuating pump is there, basically just to remove the gas from the tank or the container. Okay, connected to a vessel, and the evacuation, most important point is given that evacuation process is continued till its pressure becomes 70 centimeter of mercury vacuum. This word is very important. Okay, please mark it as a star mark, put a star mark there. Evacuation process is continued until till its pressure becomes 70 centimeter of mercury vacuum. Okay, this is the important point. Now see, calculate the mass of hydrogen pumped out. Calculate the mass of hydrogen pumped out. So there is a tank, the pressure and temperatures are given, right? Then a pump is connected, and through that pump some amount of gas is been removed. So we have to calculate how much amount of gas has been removed. How much amount of gas has been removed from the tank, that we have to solve here. Okay, so again, just from the question language you have to consider some basic, you have to put some basic assumptions. Okay, you have to consider the basic assumptions. See, first of all they have mentioned a tank. Obviously the tank will be what? Their volume will be fixed. there will be some certain volume of the tank, and that will be fixed. Okay, so ultimately, first of all, the volume is fixed for a given process. Okay, what is changing? Pressure is changing. They have mentioned the pressure is changed because as the evacuating pump is connected to the tank, definitely the pressure has been decreased. So they have mentioned that evacuating pressure is continued till its pressure becomes 70 centimeter of mercury. 70 centimeter of mercury vacuum. So the final pressure has been mentioned in the question. The final pressure has been mentioned in the question, right? So we have initial pressure. We have what? Initial pressure, right? Initial pressure we have given. They have mentioned atmospheric pressure, and they have mentioned what? The atmospheric pressure at 76 centimeter of mercury, right? The basic thing they have mentioned. The atmospheric pressure is 76. Okay. What will be the final pressure? The final pressure they have mentioned in a different way. Okay. They have mentioned 70 centimeter of mercury. 70 centimeter of mercury, but vacuum. They have mentioned a vacuum here. So we have to change the unit of this particular pressure. Okay. Obviously, you have to change the unit because this is in the absolute terms, this is in the vacuum terms. Basically, vacuum means what? The negative gauge, right? So we have to change it. How we can change it? The basic formula you should know. The basic formula is what? P absolute equals to what? P atmosphere minus P vacuum. So what will be the pressure? Absolute pressure. What will be the absolute pressure? So simply put, atmospheric pressure what? 76. It is given in the question. What is the vacuum? 70. Okay. So it will be what? 6 centimeter of mercury, right? So the final pressure can be written as that. The final pressure can be written like this. The final pressure can be written like this. 6 centimeter of mercury. 6 centimeter of mercury, right? I hope it is clear to everybody. I hope it is clear to everybody. Okay. So final pressure has been mentioned. We have mentioned the pressure in terms of different units. Okay. Because it is in a negative gauge pressure, but we have to use in the absolute terms. Okay. So 6 centimeter of mercury, it is in the absolute terms. So we have changed the conditions, changed the units basically. Now we have to calculate the amount of mass which has been removed. Okay. Or we can say pumped out. See, we have the initial condition. First of all, we have the initial conditions. So from the initial condition, we can apply what? Ideal gas equation. PV is equal to mRT. So at condition 1, at initial condition or state 1, we can say, we can apply the ideal gas equation. We know the pressure, we know the volume, we know the R, we know the temperature T, because temperature T is mentioned in the question. Okay. So everything is mentioned. You can calculate what? The M1 here. Okay. In a similar way, we know the final pressure, we know the volume. Volume will remain same because it is a tank. So definitely volume will remain same. Obviously, they have mentioned a tank which we can consider it as rigid. Okay. So rigid tank is there. So definitely volume will be constant. So again, we know from the ideal gas equation, we can apply this PV is equal to mRT. And from this, we can calculate M2. And the difference of M1 and M2 will be what? The amount of mass which has been pumped out from the container, right? So we can calculate M2 minus M1. That is the amount of mass which is pumped out from the container. Okay. I hope it is clear to everybody, right? See, in the question, initial pressure is 76 centimeter of mercury. Final pressure will be what? The 6 centimeter of mercury. Right? Right? This is clear. So we know the final pressure, initial pressure. Again, most important thing, temperature has been remained constant. They didn't mention anything regarding the temperature. So we will be assuming that temperature will remain constant. Okay, we will be assuming that temperature will remain constant. So by assuming that particular things, we can use this particular ideal gas relation. We can calculate M1, we can calculate M2, and finally M2 minus M1 will be our answer, the amount of mass which has been pumped out from the container because of the evacuation process. Okay. Gautam, no option is matching. What the answer you are getting? Please mention your answer. Please mention your answer here. Please mention the answer. What is your answer? Please mention your answer. Maybe some calculation mistake. You are doing some calculation mistake, I hope, because I think concept is clear to you. 112.33 kg. No. This is not a correct answer. 0.22 is the correct answer. Option A is correct. See, first of all, remember one thing. PV is equal to MRT, this equation. What is the value of R? What is the value of R here? Can you tell me the value of R here? Can you tell me the value of R here? See, they have mentioned the hydrogen gas. No, they are okay, Gautam, you are making some basic silly mistake, basically, I will say. It is a silly mistake. Why? Because, see, R is what? The characteristic gas constant, right? Or we can say specifically gas constant. It is what? R bar. That is universal gas constant divided by the molecular weight of the gas. Right? Remember, 8.314 is the value of universal gas constant, okay? R bar value. Basically, you have taken the wrong value of R. That's why you are getting the wrong answer. Right? So, R bar will be what? 8.314 kilojoule per kilomole Kelvin. Okay? Like this, 8.314. Simple. Okay, so after solving this particular thing, you will be getting 0.22. So it's a very basic thing. Molecular weight of hydrogen will be what? H2. Remember, the value will be 2 here. Gautam, value will be 2, not 1. Again, remember one thing, pressures. You know the initial and final pressures. See, M2 minus M1, can I write it like this? Can I write it like this? It will be what? We can say P V, volume by RT. Okay. P initial minus P final, right? We can write it like this. We can write it like this. Yes, Gautam, exactly. Hi, Paran, hi. Yes, exactly, Gautam, you are correct. P is equal to rho GH, correct. But initial and final, what is the value of initial? P initial? P initial is 76 centimeter of mercury. P final is what? 6 centimeter of mercury. So difference is what? 70 centimeter of mercury. So please see here, the value of this particular thing will be what? 70 centimeter of mercury. But we have to write it like this. 70 basically divided by 100, that's why it will be in meters. Rho GH, G value will be what? 9.81. Okay, rho GH. What will be the density of what? The mercury? 13.6. 13.6 into 10 to the power 3, right? So this is the value of difference of pressure, P final minus P initial minus P final. 70 centimeter of mercury, 70 divided by 100 basically in meters, 9.81 into G. 9.81 is the value of G and remaining is the value of density. Gautam, please make this correction, then definitely you will be getting the right answer. Right? So after solving this particular things, you will be getting 0.22 will be the correct answer. 0.22 will be the correct answer here. Okay. Gautam, please try. Definitely you will get the correct answer. Make some corrections here, whatever the mistakes you have done earlier. Yes. No, 0.22. 0.22 kg. Basically, see, again, I think you are making a mistake in what? Kilojoule. Basically, see, whatever the value of R you are getting, it is in terms of kilojoule, right? So, definitely you have to use the pressure in terms of kilojoule. See, Gautam, see, the value of R is in kilojoule, okay? But whatever the pressure difference you have calculated, it is in what? Pascal only. So, you have to maintain the units. You have to maintain the units, okay? You got it, right? Okay. So, basically, this is a very usual mistake, very casual mistake, basically, I can say. Most of the students make a mistake by using this ideal gas equation relation. See, you have to always think about the units also. Not just you have directly put the values. You got it, na? Yes, okay, no problem. So definitely you have to improve because definitely when you are using this particular relation, you have to see the units also. The left hand side and the right hand side units should match, otherwise definitely you will get a wrong answer. You will be getting a wrong answer. So 0.22 is the correct answer. Shall we move ahead? Okay, we'll be moving to the next question. Okay, now see, again this is again very important question. This is a multi-concept question. Okay, this is a multi-concept question. See, in this question, a mixture of two gases are there. A mixture of two gases A and B, having equal number of moles. It has been mentioned here. Expands in a isentropically in a nozzle. Okay, they have mentioned it is what they have expanding in a nozzle isentropically, right? The mixture of gas enters the nozzle at 300 kilopascal, 350 Kelvin. These are the initial conditions and these are the exit conditions. As far as the exit conditions are concerned, they have mentioned only pressure, and they are asking what? They are asking what the exit temperature of the gas. They are asking exit temperature of the gas mixture. Okay. Sorry. So they are asking the exit temperature of the gas. You have to calculate the exit temperature of the gas. Right? See, the two gases are there. For the two gases, different molecular weight are there. Their specific heat values are there at constant pressure. They have mentioned. Now you have to calculate the exit temperature. Now see, one basic thing. The mixture is entering into the nozzle. The process is isentropic. We know the process. We know the condition. It is going through the nozzle and it is expanding. So they are asking about the exit temperature. From the isentropic relations, the very basic relation is like this. T2 by T1 equals to what? P2 by P1 gamma minus 1 upon gamma. This is the formula that we have to use. This is a basic formula that we have to use. They have asked the temperature T2. Pressures are given. Inlet and exit pressures are given. T1 initial temperature is given, but they are asking T2 temperature. But how we can solve it? Because we don't know the value of gamma. Because gamma is for what? The mixture. Gamma is for what? Mixture. So we have to first calculate the value of gamma. And how we can calculate the gamma? This is the very most important point here. Most of the students know this particular formula, but they don't know how to calculate the gamma in this particular example because it is the case of mixture of gases. So directly you cannot use gamma is equal to Cp by Cv. They didn't mention Cp by Cv, so that you can calculate gamma equals to Cp by Cv like that. Okay. So we have to calculate the gamma, and it is one of the most important thing. This formula is the very basic thing. Most of the students already know. But important thing is that you have to calculate the gamma. And how we can calculate the gamma? This is the total crux of the question. Okay. See how we can calculate the gamma. Basically gamma, we can say we have a formula like this. Gamma R divided by gamma minus 1. Basically we can say a formula which is in which gamma is involved. We can say like this. Cp equals to what? Gamma R divided by gamma minus 1. This is the formula you should know. Cp is what? Specific heat at constant pressure. Can we use SFE? Yes, from the SFE, obviously steady flow energy equation, but there is the isentropic relation. From that T2 we can calculate. Okay, from the isentropic relation directly we can calculate the T2, but we don't know the gamma, so definitely we have to calculate the gamma first of all. So okay, let's suppose we are using directly SFE formula. Okay, but where is the enthalpy? Where is the enthalpy? See, whenever you are using the formula, see what are the number of unknowns we are required to solve the question. Whenever you are using any formula for any question, just see how many unknowns are there. Let's suppose only one unknown is there, definitely we can use it. If there are more number of unknowns, we cannot use it. Okay, right? Okay, so T2 by T1 will be there. Okay, P2 by P1 will be there. Okay, CPT, yes, Gautam, definitely. Yes, correct, absolutely, you are correct, totally. But when you are using steady flow energy equation, there will be some terms like velocity, change in kinetic energy, change in potential energy. So we don't know about anything about the velocities. We don't know anything about the velocity because they didn't mention in the question. Nothing is mentioned about the velocities, right? Nothing is mentioned about the velocities. Nothing is mentioned about the potential energies. So how we can calculate the temperatures while using the steady flow energy equation? So that's why I am asking here. We have to first calculate the gamma. Okay. So we have one relation Cp equals to gamma r by gamma minus 1. Okay. Now see how we will calculate. See, first of all, always remember this particular formulas. Cv equals to what? R upon gamma minus 1. These formulas are very important. Okay. Please note it down in your notebook. Cp equals to what? Gamma r divided by gamma minus 1. These are two important formulas. But in this particular question, there is not one single fluid. There are two mixtures of gases. So there is mixture of gases. Definitely we have to use the mixture relation. The mixture relation part. Okay. So first of all, our agenda should be such that we have to first calculate the Cp of mixture. Then only we can calculate the value of gamma from this particular relation. But again, what is the value of R for the mixture? Right? What is the value of R for the mixture? That again we have to calculate first R. So first we have to calculate what? R. R of mixture, right? We have to calculate R of mixture. What is R of mixture? How we can calculate R of mixture? Simple. Okay. R bar, again, R bar is what? Universal gas constant divided by what? The molecular weight of the mixture. But molecular weight of the mixture, okay, not a single gas, because we are talking about what? The mixture of gases here. Because we are talking about the mixture of gases. So basically this is the formula of R mixture. We know the value of R mixture. First of all, we have to calculate the molecular weight of the mixture. How we can calculate the molecular weight of the mixture? There is a direct formula. There is a direct formula that you can apply and you will get the value of molecular weight of the mixture. Okay. First, then you will be getting R mixture, then directly put the value of R mixture here. You will be getting what? The gamma value. So first of all, we will be calculating what? Molecular weight of the mixture. This is very important. Okay, molecular weight of a mixture. How we can calculate the molecular weight of the mixture? See, N1 into M1 plus N2 M2, N1 plus M2, right? See, N is what? 1 stands for the one fluid, so whatever the fluid is there. Second, 2 stands for another fluid. Okay, so number of moles in the first fluid into multiplied by what? The molecular weight of the fluid. N2 number of moles of fluid 2 and M2 is what? The molecular weight of what? The fluid 2. So this is the basic formula that you should remember, but they have mentioned equal number of moles. So if I simplify this particular thing, I will be getting what? M1 plus M2 divided by 2. Simply I will be getting this. And what is the value of M1 and M2? M1 is given at 28 plus 2. Basically I have taken the A 1 and 2, but in the question they have mentioned A and B. Okay, so 28 plus 2 divided by 2. See, 28 plus 2 is 30 divided by 2 will be what? 15. The 15 value we will be getting the molecular weight of the mixture. Now we have the molecular weight of the mixture, we can calculate the value of R mixture here. Okay, no problem. But what is the value of Cp mixture? You should calculate the value of Cp mixture. You should calculate the value of Cp mixture, right? Very simple. You have to calculate the value of Cp mixture. How you can calculate the value of Cp mixture? It totally depends on the formula, because that formula we have discussed in the mixture of gases chapter. In thermodynamics, there is a chapter called mixture of gases, in which there are number of relations, and these relations are very much important while we are solving the questions with regards to mixture of gases. In the mixture of gases, they can ask the temperature, pressures, they even ask the exergy, they even ask what? The change in entropy. So variety of questions can be possible, but that question can be solved only when you know the relations of mixture of gases. Okay. So can you tell me the answer? What will be the answer here? Can you tell me what will be the answer here? 4 options are mentioned here. Please tell me the answer. The final exit temperature of the gas. Just tell me the final temperature of the gas. Please calculate fast. Please calculate fast. Okay. CP mixture. See, formula will be like this: M1 CP1 plus M2 CP2. M1 plus M2. But you will be wondering what is the value of M1 M2, because they didn't mention about the masses. So how we can use the value of M1 or M2? See, M is nothing but what? Number of moles multiplied by the molecular weight. Simply use this particular relation. Okay. Replace the M with what? The number of moles multiplied by the molecular weight. Okay. Just simple. And definitely when you will be replacing mass with this particular formula, N will be cancelled out here. N will be cancelled out here. Okay. N will be cancelled out here. And what we will be getting here? What the value we will be getting here? Simply CP1. CP1 basically the CPA 1 plus 14. Okay. What is the value of molecular weights? You have to use the value of molecular weights. 28 plus 2. So you will be getting what? 15 by 30 like this. So please tell me the answer. You know the value of CP mixture. You know the value of molecular weight of the mixture. You will be getting the value of gamma from here. And directly you will solve the value of what? Please solve the value of, don't calculate the value of gamma here. Don't solve the value of gamma, just calculate what? Gamma minus 1 upon gamma. Please calculate this particular value, because you will be putting this value here only. You will be putting the value of gamma minus 1 upon gamma here only, directly. Don't solve for gamma. Don't solve for gamma. Just calculate this fraction, this expression. Calculate the value of this particular expression. Right? Fast. Please calculate the answer. Calculate this question. Oh, sorry. We will be putting the molecular weights here also, because we have to put the molecular weights here also, because we will be replacing mass with N into M. So molecular weight will be here also. 28 multiplied by 28 here and multiplied by 2 here, because the molecular weight of B is what? 2. Right? So it will be different. It will not be 15 by 30. So what will be the value of answer? Gautam, please reply. What is the answer you are getting? Very simple. Okay. So after calculating the CP mixture, I am just mentioning the answer here. CP value will be 1.8. 1.867. You will be getting the value of CP mixture 1.867, and the gamma minus 1 upon gamma value will be what? The value of gamma minus 1 upon gamma. It is very simple. Okay. You have to just put the value directly. 0.296. 0.296. You have to put the value of gamma minus 1. Gautam, you are getting what? 386. No, Gautam, answer will be 266. Okay, answer will be 266. First of all, check this particular value. Gamma minus 1 upon gamma will be 0.296. This is the value we will be getting. Gamma minus 1 upon gamma 0.296. And putting this particular value here, you will be getting the value of T2. You will be getting the value of T2. And answer of T2 will be 266. 266. Okay. You will be getting the value of answer 266. Okay. 266. Okay, you are getting the correct answer. Okay. So this question is very important. This question is very important for the GATE examination, because in this question two concepts are involved. First, the mixture of gases. First is the mixture of gases. Then the relation of the isentropic process. The relation of the isentropic process. Okay. So this is very important. So this is a multi-concept question. Definitely you will be getting this type of question in your GATE examination. Okay. Moving ahead. Next question. Next question. Solve this question. solve this question, try to solve this question. Again, very important question. See, in this question, they have mentioned a closed insulated container having a frictionless and smooth moving insulated partition, and it is equally divided. Total volume is given as what? The 1 meter cube volume. When both the cases are at initial pressure of 0.5 megapascal and ambient temperature of 27 degrees Celsius. Okay. Nitrogen is heated using an electrical heating element such that the volume of N2 becomes 3/4 of the total volume, right? So first of all, you have to understand the question here, okay? Please read the question carefully. A closed insulated container, frictionless and smooth moving. Frictionless is there, obviously, then because that's why we can consider the process reversible. A smooth moving insulated partition. Insulated partition means that the heat will not be transferred from one partition to another, okay? Insulated partition, and also it is moving, right? And it equally divides the total volume. Total volume is given 1 meter cube. They have mentioned the total volume 1 meter cube. When both the gases are at initial pressure, both the gases are at initial pressure of 0.5 megapascal. This is very much important. Now, nitrogen is heated using electrical heating device, and because of that only the nitrogen becomes 3/4 of the total volume. See, what is the process here? See, first of all, I am drawing a tank here. Let's suppose this is a tank. Okay, in this part nitrogen is there, in this part hydrogen is there, right? Initially both the volumes will be same because total volume is 1 meter cube. It will be what? 0.5 meter cube, 0.5 meter cube. Right? So this is very important, Nitrogen 0.5 meter cube, hydrogen 0.5 meter cube, okay? Now see, they have mentioned nitrogen is heated by an electrical element, right? Electrical element, right? Electrical element, okay? So obviously the electrical element will be giving what? Some kind of energy to this particular nitrogen. That's why it is expanding. Okay. So it is expanding such that it occupies a 3/4 of the total volume. Now please consider this particular situation very carefully, because when N2 is expanding, hydrogen gas will be what? Compressed. This is the important point you should notice here. Okay? That entire tank is insulated, and even this partition is also insulated, but it is moving. It can move, but it is also insulated. So because of the expansion of N2, hydrogen gas will be what? Compressed. And what kind of compression will be there? Adiabatic compression will be there. Okay, and obviously the frictionless piston is there, so we can assume a reversible adiabatic process. And the process is reversible adiabatic. It means what? Isentropic process. Okay, in the question they didn't mention about the process, but from the given condition, you have to assume a process for this particular case. You have to assume the process. And how we can assume? Based on the conditions they have mentioned in the question. Okay, so hydrogen is what? Compressed isentropically, because there is no heat transfer and it is going to what? Compress. It is what? Compressing. So we will be assuming the hydrogen gas is what? Compression is there for the hydrogen gas. Now they have mentioned, basically they are asking what? The work done by N2. So whatever the work done by N2 will be there, whatever the N2 has done work, whatever, because of the electrical element some energy is there for the N2, and because of that energy it is expanding, and because of the expansion of N2 compression of hydrogen gas will be there. So directly we can say the whatever the work done by N2 will be equal to what? The compression of work done on the hydrogen gas because of the what? Compression, right? So in total we can write work done, in total we can say work done by N2 is equals to what? Work done on H2, right? Very simple. Work done by N2 will be equals to what? Work done on H2, because whatever the work is done by the N2 gas, it will be transferred to what? Hydrogen gas, and work done on H2 will be what? The reversible, we can assume the process reversible adiabatic process, reversible adiabatic, basically compression. In total we can write reversible adiabatic compression will be there, reversible adiabatic compression. I hope this is clear to everybody, because this is very much important, you should notice. So whatever the work done by N2, it will be equals to what? The work done on hydrogen gas, right? And reversible adiabatic compression is there, directly you know the formula, of work done. P1 V1 minus P2 V2 divided by gamma minus 1. Simple. You can calculate the value of work done from here. So please try to solve this question, please, fast. I have mentioned the entire procedure, what is the concept here, and I have also written the formula here. Just try to solve this question fast. Try to solve this question. Again you have to calculate what? Gamma value of hydrogen, okay? Again you have to calculate the value of gamma for the hydrogen. So basically they have mentioned the Cp value of hydrogen, okay? And you know Cp equals to what? Just we have written gamma R upon gamma minus 1. From this particular relation you can calculate the what? Gamma. This formula is very important in case of thermodynamics, or even in case of what? The IC engine part. Very important formula. Directly you can get the value of gamma from this Cp value. R you already know, R bar divided by the molecular weight, right? What is the value of R? R bar, molecular universal gas constant divided by the molecular weight, right? Very important. So please try to solve this particular question, very important. I have explained the entire concept that is involved in this particular question, okay? Just you have to use this particular formula to solve the question, okay? So basically what will be the initial volume for the hydrogen gas? Definitely V1 will be what? 0.5 meter cube. But what will be the V2? That is the final volume for the hydrogen gas. See, they have mentioned what? The nitrogen occupies what? 3/4 of the total volume. So remaining volume will be what? The 1/4 volume, and 1/4 of the total volume will be what? 0.25 meter cube, because the total volume is what? 1 meter cube only. So the compression for the hydrogen gas, after the compression process, the final volume will be what? 0.25 meter cube. This is very important. It is not mentioned directly in the question. It is not mentioned in the question directly, because the whatever the conditions they have mentioned, from that only you have to conclude the final volume for the hydrogen will be what? 0.25, because nitrogen is occupying 3/4, remaining volume will be what? 1/4 only. So definitely hydrogen volume will be what? 0.25, 1/4 of total. Total is 1. So 1 by 4 will be what? 0.25. So we know the value of V1, we know the value of P2 here. Directly put the value and you will be getting the answer. Gautam, if it does not become closed system, then it is a closed system. Yes, exactly, Gautam. It is a closed system. Definitely it is a closed system. If it is not a closed system, so definitely if it is not a closed system, mass will be removing. Okay, then in that particular condition we have to think of whether it is a steady state operation or unsteady state operation, and based on that we have to solve the question. Okay, so solve this question. solve this question. Very easy. Okay, the formula is written in front of you. Just you have to calculate the values and directly put the values in the formula. What is P2? Yes, that's the very important point here. What is the value of P2? How you can calculate the value of P2? Just think about it. Very important. How you can calculate the value of P2? See, whenever the isentropic process is there or polytropic process is there, always think about the relation. Always think about the relation, because this relation will help you in solving the question. What is that relation? T2 by T1 equals to P2 by P1 की power gamma minus 1 upon gamma. But here pressure has not been mentioned. The P2 we have to calculate, but temperature is not mentioned here, right? But there is one thing also here, V1 by V2 power gamma minus 1. Okay, we know the value of V1 and V2. We know the value of P1. Only we have to calculate the P2. So from this relation you can easily calculate the value of P2 here. Okay, so always remember this particular relation. Very important relation. It will help you in dealing with the isentropic process. Okay, you can calculate the value of P2 from here and directly put the values there. You will be getting the work done here. Okay, got it? So I will be telling the correct answer here. Answer will be 200. You will be getting the answer 200 here. Okay, you will be getting the value of answer 200 kilojoule, and definitely you will be getting the negative value because it is a compression process. So you will be getting the value minus. In negative terms you will be getting the answer. What does it mean? Obviously when you are doing work on the system, the negative sign will be there, but they didn't ask about the hydrogen gas, they asked about the nitrogen gas. So we have to consider the value of 200 only. But in the options, whenever this type of question will be there in your gate examination, option will be there minus 200 plus 200, but you have to answer, you have to tick on the plus 200 answer, because they have asked for the nitrogen gas, not for the hydrogen gas. Okay, so answer will be what? Plus 200 kilojoule only, not minus 200. Okay, got the point? Okay, just moving ahead next towards the next question. This is your next question. Very simple. You can solve it in within just 1 or 2 minutes only. See, in this particular question, two reversible, obviously they have mentioned two reversible engines, Carnot type, operating in series between limiting temperatures of 1200 Kelvin and 400 Kelvin. Determine the intermediate temperatures if the work output from the engine is in proportion of 3/2. First of all, draw the diagram here. See, the limiting temperatures are given 1200 Kelvin. There is the first heat engine, then there is the temperature source, again one heat engine, and again temperature source of 400 Kelvin, right? Temperature source of 400 Kelvin. Now see, W1 is there, W2 is there. Okay, W1 is there, W12 is there, and we have to calculate the value of T2 here. That we have to calculate T2. Okay, W1 and W2. They have mentioned W1 by W2 as what? 3/2 only. They have mentioned 3/2, right? Now see how we can use this particular condition. So basically we can write 2W1 equals to 3W2. And what is the value of W1 and W2 here? Okay, just see, Q1 minus Q2 will be there for the W1 work, and for W2 work it will be what? Q2 minus Q3, right? Very simple. Okay, Q1 minus Q2 and Q2 minus Q3. I hope it is clear to everybody, right? Now see, so I will be taking some common here. I will be taking Q2 as common. Q1 minus Q1 by Q2. Okay, Q1 by Q2 minus 1, and here it will be what? 1 minus Q3 by Q2, like this only. Okay, I hope it is clear to everybody. Q1 by Q2 minus 1, okay, here Q3 by Q2. As they have mentioned, it is a reversible heat engine, so we can directly replace Q1 by Q2 as T1 by T2, and we can directly replace Q3 by Q2 as what? T3 by T2, right? So just put the values here, just put the values here. It will be like this only. T1 by T2 minus 1, 1 minus T3 by T2. Okay, and from this relation you can calculate the value of T2, because you already know the value of T1 and T3. T1 is what? 1200 Kelvin, and T3 is what? 400 Kelvin. You have to calculate T2. From this relation you can get the value of T2 here. So what will be the value of T2 here? Please calculate it fast. Calculate first. What is the value of T2 here? What is the value of T2 here? Very simple. Gautam, calculate. Very simple question. I have mentioned the I've solved the question completely, but you have to calculate. Calculation part is yours. Okay, you have to calculate it fast, because only concept is not sufficient. You have to be very quick while solving the question. Calculation part is very important. Most of the students do the mistake while calculating the questions, while calculating the solutions part. At the solution part, the whatever calculation is there, most of the students do mistakes there only. They know the concept, they know the formula. Okay, you are getting 720. Yes, absolutely correct. 720 is the correct answer. Absolutely. So why practice is required? That's why I am asking. Practice is required. Why practice is required? Because while you do enough practice, then only you get the confidence. Confidence of what? Getting the correct answer. Confidence on the concept is totally different thing, but confidence of getting correct answer is a totally different thing. Okay, you have read the concept, you know the concept. Okay, so you will be getting the confidence about the concept. Oh, I am knowing the concept completely. I know the concept completely. Okay, but you will not be able to solve the question related to that concept, because for solving question you need practice. You need practice. Okay, so when you do enough practice, then only you will be getting the correct answer at first time only. So your approach should be like this only. While solving question for the very first time, you will be getting the correct answer only. Okay, at the very first time you should get the correct answer. Okay, moving ahead. Next question. So it is related to properties of pure substance also, because properties of pure substance is very important. Properties of pure substance is very important, because based on the concepts of pure substance, we can use these concepts with any subject, any topic basically from thermodynamics. With regards to heat and work, entropy, exergy, we can relate the properties of pure substance concept from the any chapter in thermodynamics. And if we mix the concept, definitely question will become what? A somewhat difficult. Difficult for those people only who didn't understand the concepts of properties of pure substance. If you know the concepts of properties of pure substance, then you will be able to solve such type of multi-concept questions. Okay, so agenda of this particular session is what? To have a practice on multi-concept questions. Okay, you know the basic concepts, you know the formula based questions, you have already done that part, but here we will be discussing the multi-concept questions only, right? So please try to solve this particular question. So they have mentioned in a condenser a wet steam, they have mentioned the pressure, and they have mentioned also the quality. Okay, I hope you already know what is quality is there. Enters at what? Enters at 2 kg per second, right? It leaves the condenser at a saturated liquid. So they have mentioned the condition of the liquid which is exiting from what? The condenser, which is leaving from the condenser as a saturated liquid. Okay, atmospheric conditions are given. Assuming isobaric condition, find the irreversibility. Find irreversibility. Okay, find the irreversibility. Now see, first of all you should know what is saturated liquid. So from the properties of pure substance, let's suppose I am drawing a diagram of PV here. Okay, Let's suppose there is a diagram of PV here. So what is the saturated liquid state? You should identify. This is a saturated liquid line, right? And this is what saturated vapor line. So saturated liquid state will be here only. Saturated liquid state will be here only. Okay. But they have asked about what irreversibility. What is irreversibility? A Gauss-Stadler theorem. You should know the Gauss-Stadler theorem, in which the formula is like this: I, irreversibility will be equals to T naught, temperature of ambient or surrounding, multiplied by the delta S of what? Universe, or you can say the entropy generation. From this particular formula you can calculate the entropy, or sorry, you can calculate the irreversibility basically. So always remember this particular formula. See, so in first part this is a multi-concept question. How? You have to calculate the entropy change, you have to calculate the irreversibility, you should know the concepts of properties of pure substance. So this is the multi-concept questions, right? So please try to solve this particular question. So first of all you have to calculate what? The entropy change, right? You have to calculate the entropy change. You have to calculate the entropy change. Entropy change. So while calculating the entropy change, remember they have mentioned the condenser and there is surrounding part. So condenser is our system, and everything external to the condenser will be what? The surrounding. Okay. So first of all you have to calculate the entropy change for the condenser part. You have to calculate the entropy change for the condenser part. Okay. Calculate it fast. The entropy change for the condenser. Calculate the entropy change for the condenser. See, they have mentioned some data about 0.1 megapascal. Enthalpy is given HF, it means saturated liquid, HFG. HFG, the difference of HF minus FG they have mentioned. SF at the saturated liquid conditions are there. So first of all we have to calculate the what? The entropy change of condenser, right? Delta S for the condenser. It will be what? Mass multiplied by what? The S1 minus S2 minus S1 basically. So what will be the initial condition? See, in a condenser, wet steam at 0.1 megapascal with quality 0.6 enters at 2 kg per second, right? 2 kg per second is our mass flow rate. Okay, they have mentioned like this. One condition they have mentioned with a quality 0.6. So they have mentioned the quality 0.6. So first of all we have to calculate S1 then S2. Okay, S2 we know directly. How we know value of S2 directly? Because they've mentioned that it leaves the condenser as saturated liquid, and for saturated liquid the value is directly given. And most importantly they've mentioned isobaric condition, that's why we have taken the values at 0.1 megapascal only. Okay, this is clear to everybody. So see, what will be the value of S1 here? Value of S1 will be what? SF plus what is the quality X? We have to take it SFG. Okay, from this particular relation you can calculate the value of S1 here. In the similar way, enthalpy you have to calculate HF plus X HFG. You can calculate the value of H1 here. Okay, so S1 is clear, H1 is also clear, but why we need H1? Just wait, we will be discussing why we are calculating H1. But first of all you should know how to calculate the entropy change of a condenser, right? I hope it is clear to everybody. So basically in the condenser heat is rejected. What is the purpose of condenser? Heat will be rejected to what? Surrounding only, na? To the surrounding, the whatever the heat is there, it is rejected to the surrounding part. So surrounding is accepting some amount of heat, and what is the value of that amount of heat? Simply see, always see, this is the condenser, right? What is that? This is, let's suppose this is your condenser part. Fluid is entering, let's suppose at enthalpy H1 and leaving with respect to the surrounding. See, condenser, fluid is entering with enthalpy H1, fluid is leaving with enthalpy H2. So condenser, role of condenser is what? Rejection, heat rejection. So what is the total amount of heat rejection will be there? The heat rejection will be like this. Q rejection will be what? H1 minus H2. It's simple, very simple. So with H1 enthalpy, fluid is entering into the condenser, which with H2 enthalpy, fluid is leaving the condenser. So Q rejection will be what? H1 minus H2. How to calculate the molar chart? Ganesh, no. See, from the molar chart, you will be able to find some values. Whatever they've mentioned the reference point, based on that, you have to calculate the values from the molar chart. In the molar chart, different curves are there, and from the curves, you have to identify the, first of all, the state. First of all, you have to identify the state, and then only you can calculate the different parameters, different properties at that particular state. Okay. First of all, you have to fix the state. Based on that particular state, different properties are there. So from the graph itself, you can see the different values of the properties, right? You don't have to calculate the molar chart. Molar chart is already there. If they give the molar chart, from that particular chart, you can calculate the value of any property. But first of all, you should be able to calculate what? First of all, you should able to identify the state. Then only you will be able to find the different properties. Okay. So basically, we have calculated the delta S of condenser. What will be the delta S of surrounding? Basically, delta S of surrounding. So delta S of surrounding will be what? M H1 minus H2, because this is the amount of heat the surrounding is getting, and obviously surrounding is at temperature T0, the surrounding temperature. So delta S of surrounding is this one. Delta S of condenser is this one. Okay. Just delta S of a universe will be what? Condenser, entropy change of a condenser plus entropy change of a universe. Just add both of them. Just add both of these quantities. Delta S of condenser, delta S of surrounding. Just add both these values, then only you will be getting the delta S of universe. Simple. So just multiplying the T0, you will be getting the value of irreversibility. Right? So please solve this question. What will be the final answer here? So 4 options are mentioned: 629, 729, 926, 529. Calculate it fast. So see, I am mentioning the answers here. See, value of S1. The value of S1 will be 4.93. 9373. Please check these answers. S1 value will be 4.9373 and S3 is mentioned S2 basically. They have mentioned S2. S2 is what? The saturated liquid state condition of 1.3029. It is mentioned in the question, right? Value of H1. Please mark these answers. Value of H1 will be what? 1772. 1772.6. 0.26 basically. 0.26. One 7.26 kilojoule per kg. So this is the enthalpy here. This is the entropy here. Okay. So entropy, you know the value. Kilojoule per kg Kelvin unit. Units are very important. Right. So this is the enthalpy H1. Okay. So delta S of condenser. First of all, we will be writing the value of delta S condenser. Right. So value of delta S condenser is what? Minus 7.26. You will be getting minus 7.26. Okay. Minus 7.26. Mass flow rate is given. So you can multiply the mass flow rate. Okay. Minus 7.26 and entropy change for the surrounding. Entropy change for the surrounding you will be getting, because you have to put the values here. H1 is, we have calculated H1, H2 is directly given, T0 already given in the question, M1 again given in the question. So final answer by using this particular relation, I equals to T0 delta S of condenser plus delta S of surrounding. Okay, so irreversibility will be like this only. So final answer, I am mentioning the final answer here. Final answer is 529. Please try to solve this particular question. It is very important. Okay, such type of multi-concept question will be asked in GATE examination. Okay, such type of multi-concept questions. More than 2 or 3 concepts are involved here. Okay, Gautam, please check this particular answer. 529.1 kilowatt. Okay, entropy change for the condenser is minus 7.26. Right? I hope it is clear to everybody. Right? Because mass flow rate is given as 2 kg per second, na? So you have to consider that also. You have to consider that part also. Okay, Gautam, it is clear? Yes or no? It is clear to you? Any doubt or any confusion, you can please ask here only. Okay, so if there is any confusion in the question, please ask, because such type of questions are, I know the multiple concepts are involved, so it looks difficult, but if you are comfortable with all the concepts, you can solve any multi-concept questions, right? Just practice is required, and that's all we are doing here. Any doubt you can ask. Okay, I hope it is clear to everybody. So moving ahead with the next question, please. Got it? Yes. Okay, cool. So please note the solution part also. Okay, please note it. Such type of questions, it is very important. Such type of questions are like the reference questions. Similar type of question you may get in your GATE examination. Okay, obviously. Okay, now see, a 60 kilogram per hour of water runs through a heat exchanger. It is very important. See, okay, so again multiple concept question. Again multiple concept question is there. 60 kilogram per hour of water. 60 kilogram per hour of water runs through a heat exchanger. See, heat exchanger topic is in the HMT subject, and we are dealing with what? The thermodynamics subject. So multiple subject questions are also there. So you should be able to solve such type of questions. Okay, heat exchanger part is in our heat transfer subject, HMT part, but the question is related with thermodynamics. So in the GATE examination, they can mix multiple subject type of questions also. So you should be in a position to solve such type of question also, right? And how that can be possible? Just solving such type of questions, and that's why we are having the GATE booster series. Okay, so 60 kg per hour of water runs through a heat exchanger. Okay, you know what is heat exchanger? Entering as a saturated liquid, they have mentioned as a saturated liquid at 200 kilopascal, right? And leaving as a saturated vapor, leaving as a saturated vapor, right? The heat is supplied by a Carnot heat pump. The heat is supplied by a Carnot heat pump operating from a low temperature reservoir. Low temperature reservoir at 16 degrees Celsius. Find the rate of work into the heat pump. What is the rate of work into the heat pump? The amount of work that is required by the heat pump to operate such type of condition. Okay, the amount of work is required by the heat pump, na? Because it is a work absorbing device. So it needs some amount of work. So what kind of work it need for such type of operation, that we have to calculate here. Okay. See, I hope question is clear to everybody. I hope question is clear to everybody. Heat exchanger is there. See, this is your heat exchanger. Right, there is your heat pump like this, and you have to calculate this work, right? So 60 kg per hour of water runs through a heat exchanger, entering as a saturated liquid at 200 kilo. Entering, let's suppose I mentioned like this. Entering as a saturated liquid, and they have mentioned as leaving as a saturated vapor. saturated vapor, right? Entering as a saturated liquid and leaving as saturated vapor, right? Okay. See, first of all, draw the basic diagram here, because from the diagram some part is very clear. Because while reading the question, an image should be drawn. You should make an image in your mind. Rather making an image in your mind, just draw it in the paper, because it will clear many things from the examination, from the question point of view. Okay. So the heat is supplied by a Carnot heat pump. Who is supplying the heat to the heat exchanger? It is the heat exchanger, right? So heat is, how the heat is supplied? Through a heat pump only, because definitely the heat will be rejected, and that heat is given to what? The heat exchanger. That amount of heat is given to heat exchanger through the heat pump only, right? Okay. Operating from a low temperature reservoir at 16 degrees Celsius. It is given that it is operating from a low temperature reservoir 16 degrees Celsius, right? So this is the complete question they have asked here. So I have drawn the image from the diagram, from the question itself. So it is very beneficial for all of you just to draw the diagram. Whatever the diagram that is possible for the question itself, you can draw. Please try to draw such type of diagrams, because it will clear many things from the questions. It will clear many things. Okay, it will clear many things, right? So they have asked the rate of work into the heat pump. They have mentioned the pressure, saturated temperatures, HF and Hg values. Please try to solve this question. At your please try it once. Please try it once. Then we will be solving this question. Definitely we will be solving this question, but try it once. Try it once. Try to solve this question. See, from the diagram everything is cleared. Saturated liquid is entering, saturated vapor is leaving. So it is a saturation pressure, saturation process. So definitely pressure and temperature will remain same. Saturation pressure and temperature will remain same for the saturation process, because it is a phase change process. During the phase change, pressure and temperature will remain constant, right? So let's suppose it is QH, amount of heat supplied is QH. So just applying basic energy balance, we know basically it is what? MH1 and it will be what? MH2. See, this is the amount of energy entering, this is the amount of energy leaving, and this is the amount of energy entering into the heat exchanger. From basic energy balance, you can write it like this. So you can calculate the value of QH here. Very simple, very simple. You can calculate the value of QH from here. What will be the H1 and H2? What will be the value of H1 and H2? Gautam, you are getting 9.7 kilowatt. Yes, exactly, absolutely correct. 9.7 is the correct answer. So I think you are getting the confidence here. So you are getting the correct answer here. 9.7 is the correct answer. So while solving this question, your confidence will be definitely boosted. Your confidence will be boosted by solving such type of question on your own. You have solved this type of question on your own. It means that definitely you have understood the concepts. Okay, now your confidence should be boosted, and it is required for the GATE examination, right? So again, just simple thing, H1 and H2 you know, because at the condition 1 will be what? The saturated liquid, and the condition 2 is saturated vapor. So everything is mentioned here, HF and Hg, everything is mentioned here, right? So you will be getting the QH. So from the heat pump formula, COP, you know the formula of COP, it will be what? The required effect, or we can say desired effect divided by the work input. Work input will be what? W here, right? Desired effect divided by the required input. That's the formula of COP only. Whether it is for the refrigerator, whether it is for the heat pump. Desired effect divided by the work input, right? Now again this formula can be written like this: TH by TH minus TL. Temperatures are known. So from this relation you will be getting COP value, QH you know, W you can calculate here. Okay, W you can calculate here. Okay, very good, Gautam. You have solved this question very quickly. Okay, you got the correct answer also. Very good. Okay, very good. 9.77 kilowatt. Right. Moving to the next question part. Again multi-concept question. In a heat exchanger, 100 kg of saturated liquid water. Condition is mentioned. Saturated liquid water at 200 degrees Celsius is converted into saturated vapor. See, again, a heat exchanger is mentioned in which saturated liquid water is converted into saturated vapor at the same temperature. By passing a air at 2 bar at 350 degrees Celsius. So obviously in a heat exchanger, two different fluids are there. First fluid is what? Water. Another fluid is what? Air. So from the air, heat is transferred to the water, and it is what? Water is gaining some amount of heat from the air. Water has gained the heat from the air, and air has lost the heat and it is transferred to the water. Simple. The basic heat transfer process is there in the heat exchanger. Now air leaves the heat exchanger at 250 degrees Celsius. It has entered with 350 degrees Celsius and it has left the heat exchanger with 250 degrees Celsius temperature, right? And at the same, it is mentioned that at the same pressure, right? Pressure is same. Okay. Generally in most of the cases in heat exchanger we assume the pressure is same. Okay. There is no change of pressure while the heat transfer process taking place. Okay. Cp of air is mentioned. We already know the value because it is very basic thing. And ambient temperature is mentioned 300 Kelvin. Determine the irreversibility. Again, irreversibility, very important. In megajoule, due to the process of exchanging energy from air to water, heat is transferred from air to water. At 200 degrees Celsius, they have mentioned HF and Hg and SF, Hg, all the values they have mentioned. Now see. Very important. Now see. So they have mentioned what? The heat exchanger is there and saturated liquid converted into saturated vapor, right? We have to calculate the irreversibility. What is the formula of irreversibility? Again, T naught multiplied by the delta S of universe, right? Delta S of universe. Here, delta S of air you have to calculate first. Then you have to calculate delta S of water. Both the things you have to calculate. First calculate the delta S of air and then delta S of water. Okay, so water is gaining some amount of heat, air is losing some amount of heat. Okay, that you have to consider, right? So calculate it fast. Again, same formula. First of all, you have to calculate the entropy change, then only you can calculate the irreversibility part. But for calculating the entropy change, before that you should know the concepts of properties of pure substance, right? Please solve it, Gautam. Try to solve it. Try to solve this question. Okay. Heat transfer process is taking place in the heat exchanger, right? So heat is gained by the water. If you want to calculate the amount of heat gained by the water, heat absorbed or heat is gained by the water, we should write heat gained by the water. Equals to what? MHFG. Directly you can calculate MHFG for calculating the heat energy gained by water. Heat energy lost by air heat energy lost by air will be what? Cp delta T, mCp delta T. Okay, it is the constant pressure process. We can use mCp delta T for the air. Okay, right? Directly from the ideal gas relations, you can use this particular things, right? Heat energy lost by air, heat energy gained by water, right? From this relation, you can calculate this particular things, right? I hope it is clear. Please try to solve it. Try to solve this question. Okay, so for the water, entropies are given. For the water, entropies are given, but for the air, you have to use what? The relation. Entropy change of air. For calculating the entropy change for air, you can use directly this mCp ln T2 by T1. This particular formula, you can use this formula. mCp ln T2 by T1. This formula you can calculate. From this particular formula, you can calculate the entropy change. But for the water, you should know m S2 minus S1. S2 minus S1 you can calculate. You don't have to calculate because data is given in the question. Data is given in the question. You can directly put the values. Okay, you can directly put the values. So see, for the air, they have mentioned the temperatures. They have mentioned the temperature. What? The T1 initial temperature was 350, and after leaving the heat exchanger, the temperature was 250 degrees Celsius. And they have mentioned the process is what? The constant temperature process. It has mentioned at the constant temperature. They have mentioned like this. So definitely the pressure is constant. So we will be using this particular formula mCp ln T2 by T1. Otherwise, there will be another part mR ln P2 by P1. mR ln P2 by P1 will be there for calculating the entropy change. But as pressure is constant, directly we can use mCp ln T2 by T1. Okay, so from this relation you get the values and directly put the values here. Irreversibility like this: T naught delta S of universe plus delta S of air and then water. Basically, universe we have already mentioned here. Air plus water. Okay, from this relation you will be getting the correct answer. So I am mentioning the correct answer is 21.16 megajoule. 21.16 megajoule. This is the correct answer for the irreversibility, right? I hope this question is clear to everybody. Gautam. See, always remember such type of questions are very important for the GATE point of view. Okay, definitely this is the question of level 3. Advanced level questions are there. So we are discussing only the advanced level questions. In the very first question we have discussed very basic question, but most of the questions that we are discussing in the score booster are of moderate and advanced level only, so that you guys people will be prepared for the actual GATE examination. Okay, I hope it is clear. Now moving ahead to the next question, again a different question, but definitely it is very important. A different question, whatever we have discussed till now, it is different from that. Okay, a tank, a rigid, first of all they've mentioned a rigid storage tank. Rigid basically means what? Volume is constant, right? Volume is constant. Rigid basically means the volume is constant. Rigid storage tank volume is given, right? Mass 1 kg, gas is given at 30 degrees Celsius. So everything is given about the gas. Heat is then transferred to the organ from a furnace operating at 1300 degrees Celsius until the specific entropy of the organ has increased by this much. So entropy change for the gas has been given. So entropy change for the gas is given here. Okay, find the entropy generated in the process. Find the entropy generated in the process. First of all, you should remember what is the formula for the entropy generated and in which relation you have heard about the entropy generated. See, the relation is like this: delta S, entropy change, equals to del Q divided by T plus entropy generation. This is the formula. Always remember this particular formula, very important, very very important. Okay, right, just use this particular formula to calculate the entropy change. Use this particular formula. They have given the entropy change, right? The entropy change is given here, but del Q, the heat transfer, is not given. So you have to calculate the del Q, and for that you should think how you can calculate the heat transfer here. So always think about the procedure while solving the question. While you are reading the question, the procedure should be clear in your mind. What steps you are going to take while solving the question. Otherwise, before thinking about the procedure or the steps, you will be doing a random things, and the random things will result nothing. Okay, some specific procedure or steps should be clear in your mind just after reading the question. Okay, just try to solve this question. In this question, delta S is given. We have to calculate entropy generation, but Q, heat transfer, is not given. So first of all, think about how you can calculate the heat transfer part, right? Just think about it and calculate the value of entropy generation here. Okay, just try to solve it fast. Just try to solve it fast. So constant volume is there, so I can assume a constant volume process, right? So heat transfer for a constant volume will be what? mCv delta T, that is equals to change in internal energy, right? The basic formulas, basic relations you should know. For a constant volume, the heat transfer will be what? mCv delta T, right? You should know mCv delta T. But for calculating the heat transfer, you should know the change in temperature, but they didn't mention about the temperature change. They given the initial temperature, but they didn't mention about the final temperature. So again we are stuck here. Again we don't know the T2 value here. First of all, we have to calculate the value of T2 here, then only we will be able to solve Q, heat transfer part, right? So how we can calculate T2 here? So they have mentioned the increase in entropy. They have mentioned increase in entropy. So directly using this particular formula, so delta S is given, now we can use this formula mCv ln T2 by T1, right? Delta S is given. Okay, delta S is given. Basically they have given what? The specific kilojoule per kg. So we don't have to write the mass here. We don't have to write mass here. We don't have to write the mass here. Okay, we don't have to write mass. They have mentioned the entropy change 0.343. Okay, CV value you already know. Okay, they have mentioned the argon here. CV value 3.12. They have mentioned here. Okay, 3.12. Otherwise, we have to calculate the CV value also. So from this particular relation, T2 by T1. So from this relation, you have to calculate the T2, right? So you can calculate the value of T2 here, and if you able to calculate the value of T2 here, then you can calculate the value of heat transfer here. And if you are able to calculate the heat transfer here, then you will be able to solve this particular entropy generation part, right? Very simple. So always think, always make a proper flow chart while solving the question, right? First read the question carefully. Okay, write the given conditions, given parameters, given values, or whatever the given values are there, please write it down. Then just think about the procedure, just think about the steps that you have to take while solving the question. Don't try to solve the question randomly, because random things will result in nothing. Please make sure that after reading the question, you should be in a position to think of the steps that you have to take for calculating the solution part here. Okay, I hope this is clear to everybody. So please solve this question, because entropy generation you have to calculate T2. First of all, we have to calculate T2. T2 we can calculate from the given conditions, and T2, after T2 you can calculate the Q part and directly put the value here. Okay, so I am just mentioning the values here. T2 value is basically 900 Kelvin. It is what? 900 Kelvin. I am writing the final answers here. I am just writing the final answer here. And about the entropy generation part, it is 0.223. 0.223. It is the 0.223 kilojoule per Kelvin, right? Please take care of units part. It is very important. Most of the students make a mistake here. Most of the students make a mistake here while putting the unit part. So entropy generation. So from T2 you can calculate the Q part, heat transfer, and directly put here. Okay. I hope it is clear to everybody. Okay, it is clear to everybody. Okay. Now see, this question, this particular relation, I am talking about this particular relation. This particular relation is very important. Why? Because in most of the cases they will be asking about the entropy generation, or they will be asking about the heat transfer, or they will be asking about the entropy change. So 3 or 4 type of questions can be created from this particular relation. Okay. So always think about the relation part and what are the unknowns are there. What are the unknowns are there, what are the given conditions are there. Just think about it. Okay. Then you will be able to solve the question. So while framing the procedure, while framing the steps that you have to take, just think about the relation. What are the given things are mentioned in the questions? What are the given parameters? What are the given parameters? What are the unknowns? Then you will be able to solve the question. Okay. So moving ahead for the next question part. Again see, properties of pure substance, it is related to everywhere in thermodynamics chapter, but most of the cases you see this chapter is skipped. Most of the cases this chapter has been skipped by the teachers also and by the student also. They skipped this particular chapter, but it is very important to learn about the properties of pure substance in the early stage of the thermodynamics subject only. Just after the basic concept of thermodynamics, second chapter should be what? Properties of pure substance only. Then only you will be able to solve the questions of multi-type in which properties of pure substance concepts are involved. Okay. So solve this question. It is VFG. Okay. So a cylinder fitted with a frictionless piston contains 10 kg of superheated refrigerant R134, a vapor at 760 kilopascal, 140 degrees Celsius. The data is given like this. The setup is cooled at constant pressure until it reaches a quality of 25%. Quality 25%. Okay. Dryness fraction they have mentioned. And a temperature of 39 degrees Celsius. Work done in this process is, okay, first of all you should make a diagram here. Whatever they have mentioned in the question, just put it all the things in a diagram. Okay. Cylinder fitted with a frictionless piston contains 10 kg of superheated refrigerant R134 at this pressure and this temperature. Okay. Now see, they have mentioned the volume. Directly they have mentioned the volume. Volume at 760 kilopascal at 140 degrees Celsius. They have mentioned the volume here. So initial volume is given in the question. Initial volume. Let's suppose I am writing V1. So V1 is given in the question. Directly they have mentioned the V1. Now whatever the process is given, after the process the quality is what? 25%. It means dryness fraction is 25%, or we can say 0.25 basically. So we have to calculate the work done in this process. First try to make a diagram here. Then only you will be able to solve the question. Please draw the question and draw the basic diagram here. Then just think about the formula. From which formula you can calculate the work done here. Okay. Please solve the question. But before solving the question, just think of the diagram you can make here. See, a pressure versus volume diagram. Let's suppose this is some dome is there for the given fluid, and they have mentioned what? They have mentioned the superheated condition. They have mentioned what? The superheated condition. The setup is cooled at constant pressure. This is very important. The setup is cooled at constant pressure, right? Until R134 reaches a quality of 25%. So constant pressure is there. So initial initially it is in a superheated condition, but after the process it is in wet condition. Let's suppose state 2, this is state 1. So for the state 1 they have mentioned the directly volume. They have given the volume here. They have given the volume here directly. They have mentioned the volume. What is the value? 0.0315. 0.03150 meter cube per kg. Definitely the specific volume is there. Now we have to calculate the value of V2 here. Okay. For the V2 we should know it will be like this: Vf plus X Vfg. Okay. But how to calculate the work done here? How to calculate the work done? Work done is simply what? The PdV. Because as pressure is constant, we can calculate it like this: P V2 minus V1. Simple, as simple as that. But for calculating V2, we should know this particular formula. And this particular formula is related to what? The properties of pure substance concept. Okay. So for solving the such type of questions, you should know this particular relations. And you should be able to draw such type of question. Then only you will be able to understand what is the condition. State 1 is superheated condition. After some process, it is under wet condition. That is, it is within the dome only, right? I hope it is clear to everybody. So state 1, state 2. You should be able to locate the states. It is very important. While studying the properties of pure substance, you understand the concepts. And based on that concept, you should be able to locate the conditions, locate the states. Whatever the condition they have mentioned, based on that, you should be able to identify the states on the diagram itself. Okay. So if you are able to identify the states in the diagram, then definitely the concepts of properties of pure substance are clear to you. And if you are not able to identify or locate the states, definitely the concepts are little bit of understanding, little bit of more understanding is required. Okay. So just use this particular formula and you will be getting what? The work done here. You will be getting the value of work done. Just put the formula, put the this formula, put the values. You will be getting V2. V1 is already given, V2 minus V1, and pressure, constant pressure, it is already given in the question. It is already given in the question, the constant pressure process. Right? I hope it is clear. Just try to solve this question. Just try to solve this question. Okay. So I am giving you the answer here, but you should try at your own. You should try at least once. Okay. So answer will be minus 195 kilojoule, 195.61 kilojoule. Okay. So calculation part is on you and you have to calculate it. Okay. I have given the concept, I have given the basic steps, whatever the steps are required. I have given that, I have written all the steps, just you have to calculate. Okay. So answer will be what? Minus 195. I hope it is clear. Now, next question. Again, see, again this is what related to Carnot engine, related to entropy also, related to properties of pure substance also. Three things are involved here. Three things are involved here: entropy, Carnot heat engine, basically second law part, and third one, the properties of pure substance. Okay. So first of all, try to draw the diagram here. First of all, try to draw the diagram. Okay. First of all, try to draw the diagram. Okay. Determine the quality at state 1. Oh, so basically the diagram. In this particular question, they have given the diagram like this. See. This is entropy, this is temperature, right? So this is state 1, state 2, state 3, state 4. Like this. State 1, 2, 3, 4. I hope it is clear to everybody. State 1, 2, 3, 4. Okay. So the diagram is given in the question. Okay. The diagram is given in the question. You have to calculate the quality at state 1. What is the quality at state 1? You have to calculate it. Right. and for that they have mentioned some conditions. So first of all, see that they have mentioned the condition for the 300 degrees Celsius temperature. 300 degrees Celsius is here, right, like this, and second temperature, it will be another temperature will be there. But see, determine the quality at state 1. You have to calculate the quality at state 1. So they have mentioned the condition for the 300 degrees Celsius, that is the higher temperature. For the high temperature, they've given various conditions like entropy at saturated entropy, saturated liquid entropy, saturated vapor entropy, right? See, but they have mentioned the work output here. They have mentioned the work output here. A very important formula from the Carnot heat engine. Basically, you already know what is the how to calculate the work done. Basically, you know efficiency formula 1 minus TL divided by TH. This is the efficiency equals to, we can also write it like this, work divided by the heat input, whatever the heat input is there, right? Heat input. So this is the formula. You can calculate the work from here. But there is one more formula from the work point of view, from the entropy point of view. Basically, work, you can calculate the work from this particular formulas, okay? But there is one more formula for the work in which entropies are involved. Okay, there is one more formula, and it is very most important formula. Most of the students generally forget that particular formula. Please try to remember that particular formula. It is very important, right? It is very important, and that particular formula you have definitely you have heard about that particular formula, but you have skipped that particular formula. You don't try to remember that particular formula because that is not famous, or I can say that is not that much popular while solving the questions. But there is one more formula. There is one more formula that is very important, because in such type of questions you can use that formula and you can directly get the answer. Otherwise, you have to do some basic method process in which a lot of time will be consumed. Okay. So what is that formula? That formula is what? TH minus TL into delta S, like this. TH minus TL minus into delta S. Okay. I hope it is clear to everybody. This formula is very important. Please try to remember this particular formula. Okay, please try to remember this particular formula, specifically for the Carnot heat engine only. For Carnot heat engine. Right, for the Carnot heat engine only. TH minus TL into delta S. And what about delta S? You can take delta S what? S2 minus S1 or S3 minus S4. The value will remain same because 4 to 1, 2 to 3 are isentropic process. This difference and this difference will remain same. This difference, the difference of entropy from 3 to 4 or 1 to 2 will remain same, right? TH minus TL delta S. The lower temperature is given as the 20 degrees Celsius, right? Higher temperature is 300 degrees Celsius, lower temperature is 20 degrees Celsius. It has been mentioned in the question itself, right? This diagram is a part of question only. This diagram is a part of question, okay? So TH is given, TL is given, W is given. We can directly calculate the value of delta S here. Okay, we can directly calculate the value of delta S here. So delta S, we can write it what? S2 minus S1. Okay, S2 minus S1, right? We can calculate the value of S2 minus S1. And we know the value of S2 here. Why? See, at 300 degrees Celsius, they have mentioned some values. At 300 degrees Celsius, 2 is the state of saturated vapor, that is this particular thing. They have mentioned directly 5.7053 value. It is the value of what? Entropy for the saturated vapor. So directly S2 value is what? 5.7053. S2 we know, delta S we know. We can calculate delta S, simply S1. We can calculate the value of S1 here. So S2 is what? It is what? Sg at the rate 300 degrees Celsius, right? At state 2, it is value of Sg at the rate 300 degrees Celsius. I hope it is clear to everybody, right? So this point you should remember. So state 2, you have to write this particular value. It has been given in the question. Delta S we can calculate from this relation because we know the value of work, we know the value of TH, we know the value of TL. We can calculate the value of delta S. And delta S can be written as S2 minus S1. S2 we know, so we can calculate S1. I hope it is clear to everybody. So I am just writing the final answer here. Okay, I am writing the final answer here. 0.5629. Basically, we have to calculate the quality. So for the S1, see, for the S1, you will be writing what? SF plus X SFG. Okay, so SF, SFG, S1 all are known because S1 can be calculated from this particular relation. Final answer of quality is what? 0.5629. 0.5629. Right? This is the quality that the examiner has asked. So I hope this is clear to everybody. It is very important multi-concept questions. Such type of questions are very important because it will help you to boost your confidence in the subject itself, and it will try to solve or try to make different concepts clear to you. So ultimately we have discussed the entire thermodynamics concepts only, right, by solving different type of questions, okay. I hope it is clear to everybody, right? I hope it is clear. Now moving ahead, one more question, we'll be discussing one more question. See, again, this question is very important because in this type of question generally students make a mistake here. A very important formula that many of the students know, but they will mistake here. They will generally do a small silly mistake here in the formula itself, not in the calculation, in the formula itself, right? Because they know the formula different, they know different formula, but actual formula is totally different one. The actual formula is totally different that you have remembered or that you have learned in your class, right? Because generally you skip that particular conditions, under what condition that particular formula is applicable, okay? So while remembering, while learning any formulas, you should remember the conditions also. What are the conditions are there under which that particular relation is valid? That is very important, okay. So in this question, air is compressed continuously in a compressor from 1 bar 0.86 meter cube per kg to 5 bar 0.21 meter cube per kg according to a straight line relation, okay. If the velocities at the input and output are 20 meter per second and 120 meter per second respectively, then the work done by the compressor per kg of mass flow rate is, so again very simple question. They have mentioned the straight line relation. Right? Let's suppose see, this is pressure axis, this is volume axis. Directly they have mentioned the straight line relation. So as we all know, it is a open system. For the open system, what is the value of work done? What is the formula of work done? So most of the students will say minus VdP. Yes, absolutely, you are correct. Minus VdP, absolutely correct. But it is not a complete formula, right? It is not a complete formula. Please remember this particular thing. Most of the students will do a mistake here because they learn in such a way only. They learn such formula only because in the class they have taught like this only. But this is not a complete formula. Remember, this is not a complete formula, okay? So what is the complete formula? See, let's suppose integration 1 to 2 plus there will be what? C2, change in kinetic energy also there, na? Right? Plus change in potential energy also there. So always remember, generally we use this particular formula. Right? Minus VdP. So why we are using directly minus VdP? Because in that particular cases we assume no change in kinetic energy, no change in potential energy, right? So in most of the cases, yes, absolutely, in more than 90 cases we will be using this particular formula. But remember, because in all those situations there will not be any change in kinetic energy, there will not be any change in potential energy. no change in kinetic energy, no change in potential energy. So directly we can use this formula, but we should know the conditions under which this formula is applicable. So what are the conditions? No change in kinetic energy, no change in potential energy. Okay, I hope it is clear to everybody, but general formula is like this only. This is the general formula. So you have to consider what? The change in kinetic energy, change in potential energy, right? Square also, it is C2 square minus C1 square. C1, C2 are nothing but the velocities, inlet and outlet velocities, right? Okay, I hope it is clear to everybody. This formula is very important. Please note it down in your notebook. Most of the students will do a mistake here. Directly they will calculate minus VDP, and definitely the option will be there in the question itself by solving the question through this formula. Okay, so open system minus VDP is there absolutely, but kinetic energy change and potential energy change will also be there if the values are given, right? Otherwise we'll be using this formula. Okay, so always remember this type of question can be asked in the GATE examination. It is very important. So whatever questions we have discussed, it is very important for you to understand all the concepts. Okay, so we have discussed some quality questions today. We have discussed some quality questions, and that is required. For obviously you are preparing for such a great examination, that is GATE examination, in which always you will see a different type of questions, but the concept will remain same. Now definitely question is same, right? Definitely question is same. Absolutely question is same. Concept is same. Actually the concept is same. You all know the concept will remain same, but the question will be different. But if you practice a concept a lot such that you will be solving in a different variety of questions, then you will be in a position to solve any type of questions, no matter what they can ask. They can ask anything, but if you are good at your concepts, then you will be able to solve any type of questions. Okay, and you have to prepare like that only. Your preparation should be such that you can solve any type of questions, because understanding of a concept, it is required, it is prerequisite, right? But after that you should solve different variety of questions. You should solve different variety of questions, and that is very important. Just understanding of a concept it will not be sufficient. That after solving one question or two questions from the concept, then it is clear to you, everything is clear to you. No, it is not like that, because some of the concepts, important points of the concept will be cleared only when you solve different questions. Because solving question is what? The execution part, implementation part. Understanding is a step one process. Okay, understanding of a concept, basic knowledge of the concept is a step one process. Step two process is what? The implementation, execution part, and it is very important. Most of the students skip that particular part of implementation and execution. Okay, so understanding is important, implementation, execution is also important, and the last thing, the calculation part is also important, because you know the concept, you know the procedure, you know the relation, how to solve it. Okay, it's okay, but if you calculate it in such a way that you do such a silly mistake in the calculation part itself, then what is the use of the concept? No, there will not be any use. You will be getting the negative answer, you will be getting a wrong answer, and you will be getting what? Negative marks. Okay, so I hope all the concepts is clear to you from the thermodynamics subject. Next session will be on what? The application of thermodynamics, like IC engine, power plant, and RAC. All those three subjects we will be discussing in a one session, in such a way that all important concepts will be covered in the session itself. Okay, thank you so much. If you like the session, please like this session. If you seriously like this session, please hit a like button, and please try to share this particular session to your friends or your colleagues, so that they are also get benefited from this session. Okay, and if you feel you are benefited from this session, please mention all those comments in the comment box itself. Okay, if you feel if you are benefited from this session, please mention it in the comment box also. Okay, thank you so much. Thank you so much. We will be meeting in another session in which we will be discussing application of thermodynamics part. Okay, thank you so much.
Hello students, thank you so much for watching this session. We hope you enjoyed this session a lot, and there are many more sessions to go.
So do like, share and subscribe to our YouTube channel, and this GATE score booster will definitely boost your score. So thank you once again.
Hello students, thank you so much.